All right. Good morning, students. How are you all? Guess you're fine. All right. Um, what we have today is mathematics, and as you can see on your screen, the topic is approximation and error. Approximation and error. Now, most of things we do today is based on revision, because I believe should have been taught. But repetition strengthens memory, as we have it in the skin. So we'll talk about um, rounding of numbers as well as a significant figure. Now, approximation. Approximation is the process of using rounded values when presenting numerical data and making rough calculations. It also involves the analysis of outcomes arising from the rounded value. How do we mean? Let's go straight to an example. Okay, now here's an example which says we should round off the number 163.864. Now, one thing you should know, any number that lies between 1 and 4, or 1 and 4 inclusive, you round it down. That is, to round it down to 0, to count it to be 0. Okay, then numbers from 5, 6, 7, 8, 9, you round it up, you turn it to 1, and you add it to the next value or number in front of it. Okay, now question A says you should round that number to a 2 decimal place. Now, when you hear the word 2 decimal place, it means numbers after the decimal point is what you will deal with. The numbers after the decimal point is what you will deal with. Now, the question is you should round 168, or rather 163.864 to 2 decimal place. It's what you've known in your SS1 and your GS3. Now, numbers after the decimal point is what we deal with. Numbers after the decimal point is what we deal with. The numbers after the decimal point, we have 864, and to 2 decimal place will therefore be 163.86. You know that the 4 here, we round it down, so there's no way we add it to 6. So the answer remains 163.86. Okay. Then the B part says we should round it to 1 decimal place. Okay. Now, so 1 decimal place. Number after the point is 8. Number after the point is 8. That is the first number. So, like I said, 1 DP. Okay. Now, you consider 6. 6 is above 4. So you round 6, you turn it to 1, you add it to 8. And that is 1 decimal place. Okay. Then third point, question 6. We should take it to the nearest whole number. Nearest whole number. What do we do? Okay. The nearest whole number. Remember this decimal of fraction. Okay. Or we call it decimal fraction. So this is the whole number. This first part is the whole number. Now, the number before the last digit on the whole number is 8. Okay. Now, it's greater than 5. That is what you will round, you turn to 1, and you add it to 3. So you have 164. That is whole number. Nearest whole number. Okay. Then a deep point says you take to the nearest 100. Nearest 100. Now, if you count it, this is 163. Now, we get to 100 first. The next 100 would be 200. Now, when we look at 6, this 6 is above 5 or above 4. So that's when you change it, it will turn to 1 and you add it to this 1. So you get your answer to be 200. So that is to the nearest 100. It's nearer to 200. 100. Okay. Near to 200 compared to 100. All right. Are you all following? Good. What about significant figure? Like I said, all this kind of a revision to you, but it's better we do it because repetition strengthens memory. Okay. Now, let's talk about significant figure. Significant figure. On your screen, you see that the significance of a digit depends on its position in the number. The significance of a digit depends on its position in its number. As you should also know that the first significant figure in a decimal fraction is the first non-zero digit in the fraction. I repeat, the first significant figure in a decimal fraction is the first non-zero digit in the fraction. Example 2, we have says you should round off 146.82. Okay, to one significant figure. To one significant figure. What will that be? B part says you should round it to 2 significant figure. Then C says round it to 3 significant figure. Then D says to 4 significant figure. So know that 1 is the most significant of these all, followed by 4, followed by 6. Now, 4 is more significant compared to 6. Then after 6, we have 8 and we have 2. Okay. Now, 2 significant figure, it means you need 2 numbers. There must be 2 numbers here. Now, third number here is 6. So it's what you round up, turn to 1, and add it to 4. So this will be 150. Okay. For 3 significant figure, we have 1, 4, 6. So are the 3 numbers. Now, when you consider the fourth number to be 8, which is also greater than 6, greater than 5, it's what you round up to 1, you add it to the next value. Okay, so when you do that, you have 147, 3 significant figures. Then for 4 significant figure, what will you do? You count the number 1, 2, 3, 4. Okay, now 2 is lower than 5, than 4. So we round it up, or rather we round it down to 0, and there's nothing we can add to it. So we still have 146.8. Okay, now I need somebody to tell me what this answer is. You can type it on your chart and you can display it, or you can flash it. Then I'll see the answer. I'll tell you you are right or wrong. Okay. Anybody? Anybody can raise hand, tell me what the answer to question A is. Kauta, you are displaying videos. Stop that. Habib Salami. Okay, Zainab Abdul. Zainab Abdurrahim. What's your question? Zainab, I can hear you.
The answer is 100.
The answer is 100. Thank you. Brilliant of you. Okay. Next, we move to the next slide. Okay. Here's another example. Remember, I said that, yes. Remember, I told you that in the decimal fraction, the first non-zero number is the most significant number. Okay. Now, on your screen, you will realize that when you have to round off 0.002, let me just take it to slideshow. Okay. All right. So we realize that the first significant figure, or to take it to one significant figure, the first non-zero number there is 2 in that decimal fraction. The decimal fraction is 0.00. Look at what I'm saying. Now 0.002487. So this side is called the decimal fraction. Okay, it's called the decimal fraction. Now, the first non-zero, which is 0 to 0, then the first non-zero number there is 2. Okay, so that is your first significant number. So if you are taking to one significant figure, it will just be 0.002. That is one significant figure. Okay, so if you take it to 2, the second is 4. We realize that 8 can be rounded up to become 1, which will then be added to 4. So we'll have that to be 0.0025. That is 2 significant figures. Okay, what about the 3 to 3 significant figure? The first non-zero, this will be the first one, this is the second, and 8 is the third. But the fourth number is 7, can be rounded up to become 1 and added to 8. So we have 0.00249. That will give us 3 significant figures. Okay, so we have 3 significant figures. Okay, so now the real topic for today, all those we've done is significant figure, rounding of number either down or up to decimal places, is a revision to you because you have done it already. Okay, now the real work for today is error, percentage error, because most of the time we make measurement, volume, we calibrate if we use especially in chemical lab, and if you use lab, we make use of length, distance. But I want to tell you that every of the measurements, no matter how carefully they are made, they are not exact. Okay. Now measurements are most of the time they are approximate, just approximate, because during instrumentation, you make use of some precision to calculate or to carefully build an instrument when you use measurement. There is no way we make use of the same, the same materials during the instrumentation. That's why I said measurements are what approximate. So you should bear that in mind. Another point is that what we are talking about here today is not really about the measurement, but to decide that degree of error in that measurement. Okay, the degree of measurement. Some will say, the error is 0.2 now, is inconsequential, is too small, 0.02%. But what is the degree of that error? What can the error do towards people taking a decision? Take, for instance, most of you will become a civil engineer, and some other wonderful profession like that. What are these errors? What will be their consequence in the totality of the work? Then this degree or the level of error is always measured in percentage. Okay, that percentage will therefore guide you as a decision maker to accept the level of error. Either you can either accept it or you discard it. Okay, the third point is that the error that is made in any measurement will either be positive or negative. Okay, you should bear that in mind. It will either be positive or negative. Okay, I move to the next slide. Now, calculating error. Percentage error is given as error over the measurement times 100%. Error over the measurement times 100%. And in case that you know the true value, there are some standard value like that. So once you know the standard value and you get to a certain place, you measure it is maybe lower than the standard value or higher. Okay, now for that, percentage error is given as error over the true value multiplied by 100%. Okay, just bear that in mind whenever you come across it, error. And how do you get your error? Error will therefore be, since you know the true value and your measured value, if it's lower or if it's higher, you subtract the true value from it to get your error. The error over the true value multiplied by 100%. So from there you get the percentage error. Okay. Now, here's an example. Since the length of a pole is measured as 5 meters to the nearest meter. What is the range of its actual length? What is the range of its actual length? Okay, that is one. The other question says calculate the percentage error. Calculate the percentage error. Okay, now to answer the first question, the solution is here on the screen. It says, since the measurement is given to the nearest meter, therefore the actual length of the pole will be in the range of 4.5 to 5.5. How do we mean? We have the length to be 5. Okay, 5 meters. Because it's given to the nearest meter, it means if you have it to be 4.5, okay, rounding this to the nearest meter will give you what? Will give you 5 meters. Okay, we've done it early. Now, this will also be by right 5.49. Okay, 5.49. Okay, at the end of the day, you have this to be what? 5.5. So we're procuring more error. For 5.5, you can also take it down to become 5. Okay. So we say that the actual length to be in this range 4.5 to 5.5 meters. Okay. Even though the true length or the true measurement is given as 5 meters. Okay, so this is the range because it is taken to the nearest meter. Okay, now how do we calculate the percentage error? How do we calculate the percentage error? To calculate percentage error, what was the error? Okay, to get the error, we have 4.5 minus 5. That will give us minus 0.5. Okay, we also have 5.5 minus 5. This will give us positive 0.5. So that the error is plus or minus 0.5. Plus or minus 0.5. I hope you can see the board. Okay. Now, let me write it up for you to see. Okay. Now, percentage error, as we have it, is giving us the error over the measurement of the true value, okay, times 100%. Okay, 100%. Okay, therefore you have plus or minus 0.5. The true measurement is 5 from the question, multiplied by 100%. Okay, so this is the true. It's a very simple sum for you. You can divide directly, multiply by 100, or you can multiply by 100 first before you divide by 5. Now, if you multiply by 100 first, let me take this up. Okay. So you have 5012. So plus or minus 50 over 5. Then percentage. Okay. So when you divide this, you have plus or minus 10%. Okay. So this is the percentage error. This is the percentage error. That is, you have done for positive and for negative all the same. Okay. Going by the range given. Okay. Are you done writing? Okay, I'll move to the next slide. To the next slide. This is taken from my question. It says a stick of length 1.75 meter. A stick of 1.75 meter is measured by a boy as 1.8 meter. Find the percentage error in the measurement. Okay. It means that we know the true length. The true length is giving us 1.75. True length or true measurement is 1.75 meter. Okay. Now, a boy, a student, maybe like you, measure that same stick to be 1.8 meter. Okay. Okay. New length as measured by the boy, we have to be 1.8 meter. So to get the error, will now be the new length. Okay. The new length minus the true length. But one thing I want you to know is that you have the true length first because that is what is known, minus the new length. So that will have 1.75 minus 1.8. Okay. Now, do your calculation carefully. Take well 0.05. Yeah. So we have minus 0.05. Minus 0.05. So this is the error in the measurement. Then we call our percentage error. Our percentage error is giving us error. Okay. There is always mark for you putting the formula over the true value times 100%. So error is minus 0.05. Okay. Over the true value 1.75. Okay. Times 100%. We have negative because at the end of the day, it must be removed from the length of, the new length that we measured for us to get the length given. Okay, now, like I said, depending on how best you know how to, just multiply through 1, so that this will be 5 over . We do the division, you will have minus 2.857. Okay, plus 2.857%. You can do it, you can leave it in fraction. Okay, leave it in fraction. You have 2 number 6/7%. Okay, so that is the percentage error. You know, the true measurement is 1.5, but the boy measured it to be what? 1.8. Okay, so this is the error which will be subtracted from the length for us to get the true length. Okay, Okay. Read the classwork and I would like you to try it. The question says, a student draws a line. A student draws a line and says it is 10 centimeters long. When it is carefully measured, the true length is, remember, the true length is 10.2. What is the percentage error in the drawing? What is the percentage error in the drawing? So quickly sketch that down. Let me see how you are following the class. Okay. Okay. Okay, to check the example, so we have the true length is given to the 1.75, but the body measure it to the 1.8. Okay, so the difference between 1.8 and 1.75, we have it to be 0.05. Okay, remember that the true length is 1.75. So from there, we have the percentage error over the true error. Okay. So this is, we have this to be positive. The new length minus the true length. Yeah. So the class was given to you. A student draws a line and says that that line is 10 centimeters long. Now, when we therefore use a wonderful and sophisticated equipment to measure it, we realize that that line is actually 10.2 centimeters. Now the question says, find the percentage error. Okay, find the percentage error. The two idea is that the new length minus the true length. Okay, so has anybody done it? Any response? Check chat. That is brilliant, 2%. Is enough, that's brilliant of you. Aziz, also wonderful. All right. For those that do not understand, there will be a YouTube message, YouTube video that you can check again. Okay, just download it. From there, you. Okay. So Sophia, that's good, wonderful. Weather, that's brilliant. Dapo, brilliant, 2%. Sunny, wonderful, 2%. It shows you are following. That's wonderful of you. Now, there is something I want you to know before you write the assignment. So those of you that submit assignment to NTI